In this video, we're going to find the equations of cosecant and secant functions. I'm going to start out with a secant function. So, the secant function, if you remember, is a reciprocal of cosine. So you can see that they've got the cosine graph graphed in the middle of this function. Now, some things that are important is that they tell you the a value is negative. So we have f of x is equal to a secant b x minus c plus d. So they want us to find a, b, c, and d. So let's go ahead and write down what we need to find. Now, one thing we need to, first thing I do is I always look for d. So we can go ahead and split the function. And it's kind of weird to split the function with secant and cosecant because you're not actually touching the function. You go and trying to go directly in between, I'm going to call them parabolas. You want to be right in the middle of the parabolas to see the shift. So this is at 3. So this is 2, this is 4. So this would be at an x value of 3. That means it's been moved upwards for a total of 3. So my d value is 3. My a value then is going to be essentially the distance that these parabolas are from the center of my graph. So I've got a distance, I'm at 3, my distance, this is 4, so my distance up would be 1. So my a value is 1, but they tell me it's negative, so I'm going to write negative 1 there. So then I got to find my b value. So to find my b value, I need to first find the period. The period is going to be 5 pi over 12 minus this negative 4 pi over 12. So I'm looking for when it starts to repeat again, basically trough to trough or peak to peak. So 5 pi over 12 minus negative pi over 4. So this is really 5 pi over 12 plus, multiply this by 3, this would be 3 pi over 12. So I end up with 8 pi over 12, which if I reduce this would be 2 pi over 3. So how did I get 2 pi over 3? Well, we still use 2 pi over b, just like in the previous video. 2 pi over b is going to equal 2 pi over 3. So what would b be? There, b is 3. So we can go ahead and write that down. Now the c part, that's a little bit more difficult because this is negative. We're actually going to be looking at these two values here, and we're going to try to see which one is closer to the y-axis. So secant, I'm going to kind of write this out. Secant is equal to, so secant of 0 degrees is equal to 1 over cosine of 0 degrees, which is 1 over 1, which is 1. So secant's defined at 0 degrees. So because secant's defined at 0 degrees, that means its coordinate for secant is actually, it starts at 0, 1. So I'm going to go ahead and say that starts at 0, 1, meaning this one of these peaks is usually sitting on the y-axis, right? 0, 1. But because this is negative, it actually starts typically at 0, negative 1. Okay? So then we want to be looking at this y-axis. We want to pick the point down below that is closest to the y-axis. And you can see that negative pi over 4 is closer to the y-axis than 5 pi over 12 is. So this one is going to be the shift. That's what we're looking for with C here. So the shift is negative pi over 4, so I'm going to go ahead and write negative pi over 4 here. And then I can rewrite my function up here as negative 1 secant 3 x minus pi over 4. Actually, it's plus pi over 4 because you're subtracting a negative. So plus pi over 4. and then plus 3. So that's how you go about finding the equation for a secant function. The key here is starts at 0, -1. That's going to be different for cosecant. So because it starts at 0, -1, I know the y-axis is where I need to measure from to find my c value. That's going to change for cosecant. So let's look at one of those. Let's go take a look at a cosecant graph. Here, we'll use this one down here. Okay, we've got a cosecant graph. We're again going to write out f of x is equal to a cosecant b x minus c plus d. We're looking for a, b, c, and d. So I'll start by finding d first, again, like I have in every problem so far. You're going to split the middle of the cosecant function. We're at -1 there. And that means we've been shifted down from the x-axis down to -1, so that means d is -1. Then I'm going to look at the amplitude. The amplitude, so the distance basically from the middle to the top or the middle to the bottom is a distance of 1. So we're going to write a is 1. But they tell me that a is supposed to be negative. So I'm going to go ahead and put a -1 on a. I got to find my b value, so I'm going to find my period first. To find the period, I'm going to take 5 pi over 12 and subtract -7 pi over 12, which will give me, that'll be an addition, so I end up with 12 pi over 12, which is pi. So I'm going to again use the 2 pi over b is equal to pi. Multiply by b, so 2 pi is equal to pi times b. Then we divide by pi. And I get 2 is equal to b. So my b value here is 2. Now, cosecant, okay, this is going to be a little different than secant. So I'm going to come down here and I'm going to say that cosecant of 0 degrees is actually equal to 1 over sine of 0 degrees, which is equal to 1 over 0, undefined. So cosecant's undefined at 0 degrees. So it actually doesn't start on the y-axis. Let's go ahead and do now cosecant of 90 degrees. Cosecant of 90 degrees would be 1 over sine 90, which is 1 over 1, which is 1. So we're going to say that our starting point for cosecant is pi over 2, which is 90 degrees, comma 1. Now we've done some things to this starting point to start that I need to adjust for to figure out which one of these points I want to find my c value with. So the first thing we've done to this piece is we've changed this value from starting at 1 to starting at -1 with that a value. And we've also subtracted 1 from it. So we started with pi over 2 comma 1. That's the normal function. But then we end up multiplying. Our value 1 by -1. And then we subtract 1 from it, which will actually give us, we're starting this thing at pi over 2, comma, that'd be -1 minus 1 is -2. But then we also took the period and we halved it. Like our period is pi when it's normally supposed to be 2 pi. So this halving of the period halves this value because we started at pi over 2 comma 1. So if I half the asymptotes, and you can see this on a graph if you go to Desmos, but if you half the asymptotes for the cosecant function, it will move this starting point in by a half. So it's basically you're dividing this by 2. So that actually changes this to now we're looking at pi over 4 comma, negative 2. Okay, because we have to account for this b value. So we have to adjust this point to be pi over 2 comma, pi over 4 comma, negative 2 is actually where we start, which would be, let's see, pi over 4 comma, negative 2. This is pi over 6, pi over 3, pi over 4 is going to be somewhere in here. So we're looking like that's the point there where we would go ahead and look. So our shift is going to be like this point's clearly a longer ways away from this point. So we're looking at 5 pi over 12 to figure out our c value. So we're going to say that we're at pi over 4, and we're going to subtract 5 pi over 12, which is going to give us 3 pi over 12 minus 5 pi over 12, which gives us negative 2 pi over 12, which is negative pi over 6. So my shift will be to the right. It'll be from here to this direction, pi over 6. So I need to go ahead and I don't want to use a negative here. I actually want to use, because it's a right shift of pi over 6, so I'll use the positive version of that. So I end up with negative 1 cosecant 2 x minus pi over 6 minus 1. So the key here is, where does cosecant start? This is probably the most difficult one to graph with all the shifts and stuff, because where does it start and how do these values affect it, okay, to then figure out what the actual shift is. Okay, and that's us going through looking at the a value, the d value. So the a value affects the, it's going to affect the y value. This is going to affect the y value. And then the b value actually affects that x value to make it start at pi over 4.